Let's look at the function y equals inverse sine of x. We want to find dy dx. Now to do that, I will rewrite this by getting the sine of both sides. So get the sine of the left hand side and then get the sine of the right hand side. And use the fact that the sine of the inverse sine of x is just x. So we just turn this round. Y equals inverse sine of x is equivalent to saying that sine of y equals x. The next thing we do now is differentiate both sides with respect to x. If we differentiate the right hand side with respect to x, we get dx with respect to x. Put this x in brackets if we like. Now, the right hand side is quite straightforward. The derivative of 1x with respect to x is just 1. Now, what about the left hand side? Now here we have to use implicit differentiation, which is covered in a previous video. Well, we have the derivative of a trigonometric function. So the first step is to differentiate this function. So if you look back on the derivative of trigonometric functions, we had what was called the power function angle rule, where we differentiate the power first if there is a power. Like for example, if this is sine squared y, we differentiate the power to get 2 sine y. After sine cubed y, we'd have differentiate the power to get 3 sine squared y. We don't have a power in this function here. So in the power function angle rule, we can forget the power part and go to the next part, which is the derivative of the function. And then we get the derivative of the angle, which is y. The derivative of the sine function is cos. And we just copy down the angle, which is y. That's the function part of the power function angle rule. Well, there's no power part in this. The next part then is the angle part. We differentiate the angle with respect to x. So we differentiate y with respect to x. Well, we don't know y as a function of x, so we just write down dy dx for the derivative of y with respect to x. So we covered this in earlier videos. In earlier videos, we did not see things like sine of y. We might have seen things like sine of x squared plus 3x, and when we differentiate it, we get the derivative of sine is cos. Just copy down the angle, and then we multiply this by the derivative of the angle. The derivative of the angle is, here in this case, is 2x plus 3. So this kind of thing is covered in previous videos. So the derivative of sine of x squared plus 3x is 2x plus 3 multiplied by cos of x squared plus 3x. So this process here is implicit differentiation. We have to use implicit differentiation because y is given implicitly as a function of x, whereas originally y is given explicitly as a function of x. So now to get dy dx, we just divide across by cos y. Of course, dy dx is not part of the argument of this cos function. It's not part of the angle. So we just divide across. So we get dy dx equals 1 over cos y. Now we want dy dx in terms of x, not in terms of y. See, we have y given in terms of x initially. So we want dy dx in terms of x. So how do we write cos y in terms of x? Well, we use the fact that the sine of y is x. And then we use a very important identity. That identity is cos squared y plus sine squared y equals 1, no matter what y is. So you'll see this identity in tables. We want to get the cos of y in terms of sine of y, so we just rearrange this to get cos squared y equals 1 minus sine squared y, and then we just get the square root of both sides. So now we can write 1 over cos y as 1 over the square root of 1 minus sine squared y. But what is sine of y? Sine of y is just x. I'll write it down again here. Sine of y is x. So that means if we square both sides, sine y times sine y can be written sine squared y. X times x is x squared. So we can write this as 1 over the square root of 1 minus x squared. So that's the derivative of inverse sine of x with respect to x. It's 1 over the square root of 1 minus x squared. Now let's look at the function y equals inverse cos of x. Well, we can get the cos of both sides of this. We can write this as cos of y equals x, and we do implicit differentiation. Differentiate both sides with respect to x, like you saw before. The derivative of cos y with respect to x, well, we look at the function which is cos, we look up the derivative of the cos function, you will see that it's minus sine. We just copy this angle down again, and by the chain rule we must differentiate the angle, which is dy dx. We differentiate the right hand side with respect to x, that's just dx which is 1, just like before. For y equals inverse sine of x, we had that situation. The derivative of x with respect to x is 1, because it's just 1x with respect to x. To get dy dx then, we just divide across by minus sine y. Now, we want dy dx in terms of x. We see that cos of y is equal to x. So, how can we get sine of y? Well, just like before, we use the identity cos squared y plus sine squared y equals 1. We rearrange this to get the sine of y. Sine of y is the square root of 1 minus cos squared y. Sine squared y is 1 minus cos squared y. To go from sine squared y to sine y, we get the square root. And we know that since the cos of y is x, then the cos of y all squared, or cos squared y, is x squared. So dy dx is minus 1 over the square root of 1 minus x squared. Finally, we have y equals inverse tan of x. Get the tan of both sides. So we get the tan of y on the left hand side. The tan of the inverse tan of x is just x. Differentiate both sides with respect to x. Well, here we have to use trigonometric differentiation. The function is tan. If you look up the derivative of tan, you will see that it is sec squared. Our angle is y. By the chain rule, we differentiate this angle. And the derivative of x with respect to x is 1. So that tells us that dy dx equals 1 over sec squared of y. So you can just look up the derivative of tan function. You'll see that it's sec squared. Now, what is sec squared of y? Sec squared of y means 1 over cos squared of y. You can look that up as well. Sec of y is 1 over cos y. So, well, I'll just write it down here. Sec of y is 1 over cos of y. If we square both sides, we get sec squared y equals 1 squared is 1 over cos y times cos y, cos squared y. So we have 1 divided by 1 over cos squared y. Well, we can just multiply above and below by cos squared y. These cancel out, and we get cos squared y over 1, which is just cos squared y. So dy dx equals cos squared y. Now we want cos squared y in terms of x. So we go back to the fact that the tan of y equals x. So if the tan of y is equal to x, we should be able to find what the cos of y is in terms of x. Well, to do that, we can write the tan of y as sine of y over cos of y. You can look that up. And then you can square both sides of this to get sine squared y over cos squared y equals x squared. Now, we're interested in cos squared y. What is cos squared y in terms of x? We're interested in getting this thing here in terms, this is dy dx. So we're interested in this in terms of x. But we have sine squared y on top. Well, we can replace sine squared y with 1 minus cos squared y. So we use the identity that cos squared y plus sine squared y equals 1. So sine squared y is just 1 minus cos squared y. And we can break this down. We can write this as two fractions. We can write it as 1 over cos squared y minus cos squared y over cos squared y. Cos squared y over cos squared y is 1. And then we can isolate cos squared y, bring the minus 1 over, becomes plus 1. Get 1 over cos squared y equals x squared plus 1. Turn both sides upside down, so cos squared y over 1, or just cos squared y, is 1 over x squared plus 1. So dy dx is equal to cos squared y, which is 1 over x squared plus 1. So now we have the derivatives of three inverse trig functions, and you can look up these in tables. I just want to do one example. I want to get the derivative of y equals inverse sine of 3x squared plus 2. So we have to look up inverse sine of x. We see that the derivative is 1 over the square root of 1 minus x squared. Now we're going to have to use the chain rule here. So we just pretend that this here is a single term. You could call it u if you like. So dy dx is got by copying this out and replacing x with 3x squared plus 2. And we have to square this. So I'm using the chain rule here really. You could think of this as dy du, where u is equal to 3x squared plus 2. So this would be dy du. It's 1 over the square root of 1 minus u squared. This is u in here. U is 3x squared plus 2. And then we multiply by du dx. So we have to differentiate this here to get 6x. So our answer would be 6x divided by square root of 1 minus 3x squared plus 2 squared. So just to recap again, this is like dy du. It's 1 over the square root of 1 minus u squared, where u is equal to 3x squared plus 2. And this term here is du dx. We differentiate 3x squared plus 2 with respect to x, and we get 6x. And you see that dy du times du dx is dy dx. So that's how we would differentiate this kind of function. And we do something similar for inverse cos and inverse tan.